Hi, let me tell you about another great Manning book. Learn Concurrent Programming with Go, written by James Kudayar.
Concurrent programming is essential for developers to create scalable applications that maximize hardware use. This book targets those familiar with Go or similar C-style languages but new to concurrency. It covers concurrency in operating systems, race conditions, process communication, advanced topics like deadlocks and spinning locks, and more. Concurrent programming enables simultaneous task execution, allowing us to model concurrent real-world applications. Nowadays, most applications need to respond quickly. Think, for example, about air traffic navigation, logistics, and even online shopping. As hardware advances with multi-core processors and cloud computing, developers must adopt concurrent programming to efficiently scale software and meet rising demand. We can improve throughput through horizontal scaling when multiprocessors are available. If multiprocessors are not present, we can still minimize response time using multitasking and interleaving. Hardware interrupts and operating system mechanisms facilitate seamless multitasking, improving software responsiveness. Go is designed for high-performance concurrency, featuring Go routines for concurrent execution and channels for communication. Go routines are lightweight and managed by Go's runtime, simplifying concurrent code writing and scaling with hardware. Go's concurrency model is influenced by CSP, focusing on synchronized channels to minimize race conditions. It also includes traditional concurrency primitives for scenarios where using memory sharing is more appropriate. The book teaches how to use concurrency tools and shows how some of these tools are built. This enhances overall understanding of concurrency. The idea is that if you know how to build a particular concurrency tool, you will know how and when to use it. Performance scalability measures how well a program speeds up with increased resources. Imagine building a house. Hiring more builders initially speeds up construction, but eventually, putting more people on the job doesn't get the job done quicker. This is due to certain parts of the job being sequential. This illustrates Amdahl's law, which states that the non-parallel parts of a task limit scalability. In contrast, Gustafson's law suggests that as resources grow, the problem size can also increase, allowing for continued speedup if the non-parallel portion remains constant. For example, in gaming, while more processors might not boost frame rates indefinitely, they can be put to other use, such as to enhance graphics. This demonstrates how extra resources can be effectively utilized as they become available.
Get this book at manning.com